Alright, so today we have the integral of sine squared x dx. Now, there's a few ways we can do this integral. One is integration by parts, another one is by substitution. So in this video, I think I'm going to do a u substitution because I'm not the biggest fan of integration by parts. And to also show how u substitution can be done. So, anyways, we look at the integral. We have an integral of sine squared x dx. Trig functions were hard enough. Now we have trig functions on powers. So I think what a good idea would be is if we could reduce the power, right? Maybe get into to the first some trig function to the first power. That'd be easy to integrate because then we can just substitute and stuff like that if we need to. And luckily we can do that because we have the identity cosine of 2x is equal to 1 minus 2 sine squared x. So we could do, really, is we could solve for sine squared x and then integrate the resulting expression, right? The expression with the cosine in it. So we can subtract by 1 on both sides, divide by minus 2, all that. We get that sine squared x is equal to 1 minus cosine 2x over 2. Now we can integrate this. This is easy. We have a trig function to the first power. This is easy to do. And we have a 2x. That's easy. We can just do a substitution and fix that. So right now we have the integral of 1 minus cosine 2x over 2 dx. Right, so we have everything divided by 2. We can just rip out a 1/2, take it out of the integral. So 1/2 integral 1 minus cosine 2x dx. Right, so that means we have 1/2. We're going to break apart the integral. So 1/2 times integral of dx minus integral of cosine 2x dx. I think I might be running out of space, but we'll see. So integral 1 dx, that's easy. Like, this is x. Integral of cosine 2x dx. That's a little harder, but we can just do a substitution. Substitute at 2x. So I'll do it on the side. Integral of cosine 2x dx. Right, that's easy. We can do a substitution. We'll just get we'll need to figure out a multiplication by the derivative of 2x. So derivative of 2x is 2, right? So we'll just create a multiplication by 2, so we can lump the 2 in dx into a du. So I'll rewrite the integral as this 1/2 integral of 2 cosine of 2x dx. So I got that. I got a multiplication by 2, right? So I can say u is equal to 2x. And then du is equal to 2 dx. We have a 2 and dx right here. We'll lump that into a du. So get 1/2 integral cosine u du, right? And we know integral cosine u is just sine of u, right? And then u is equal to 2x. So unsubstitute all that. We'll get 1/2 sine 2x plus c. Right, so that's our integral of cosine 2x. We'll get rid of actually no, we'll keep the plus c because that's good practice and all that. So let's see here. We know integral of cosine 2x, right? So we'll plug that into here. So far we have 1/2 integral dx, that's just x, minus integral cosine 2x, that's 1/2 sine 2x. I'll leave off on the plus c for now. We'll add it on at the end, right? And now we'll just simplify and we'll be done. So distribute the 1/2. So our final answer is going to be x over 2 minus sine 2x over 4. Ideally, you can see it. I think you can see it now. Yeah. So sine 2x over 4 plus c. Right, so x over 2 minus sine 2x over 4 plus c. That's our final answer. So that's the integral of sine squared x dx. So yeah, not too bad. So it really isn't a bad integral when we do substitution. I suspect integration by parts may be faster depending on how good we are at it. But yeah, not too bad. So not a bad integral really. And stay tuned for more cool stuff.